Nuclear power plants are complex, but the core idea is straightforward. They use controlled nuclear fission reactions to produce heat, which is then converted into electricity. Unlike fossil fuel plants, nuclear plants generate energy with minimal greenhouse gas emissions, making them a key player in sustainable energy solutions. At the heart of a nuclear power plant is the reactor core. This is where nuclear fission happens, releasing vast amounts of energy. The fuel for this process typically comes in the form of fuel rods made from uranium-235 or sometimes plutonium-239. When a neutron strikes the nucleus of a uranium atom, it causes the atom to split, or fission, releasing heat and more neutrons. These neutrons continue the reaction, forming a chain. To manage this reaction and control power output, we use control rods. These rods, often made from neutron-absorbing materials like boron or cadmium, can be inserted or withdrawn from the core to adjust the reaction rate. Lowering them absorbs more neutrons, slowing the reaction; raising them speeds it up. This control allows us to regulate the heat output, maintaining a stable and safe energy production rate. Now, to handle the intense heat generated, we need a coolant system. In most reactors, water serves as both a coolant and a moderator. It absorbs the heat from fission, preventing the core from overheating. This hot coolant then flows through a heat exchanger, where it transfers its energy to a secondary water loop. In this secondary loop, the water turns to steam, which is then used to generate electricity. The steam generated in the secondary loop drives a turbine, a device with blades that spin when pushed by high-pressure steam. This turbine is connected to a generator that converts mechanical energy into electrical energy. This electricity then goes to the power grid, ready to be used in homes, factories, and offices. Safety is paramount in nuclear power plants. Multiple systems are in place to prevent accidents and mitigate risks. For instance, there are backup cooling systems to ensure the reactor stays cool, even if primary systems fail. Containment structures around the reactor core prevent radiation leaks. These structures are built to withstand both internal pressure and external forces, adding a critical layer of security. In the US, two main types of reactors are used: pressurized water reactors, PWRs, and boiling water reactors, BWRs. In a PWR, water under high pressure circulates through the core but doesn't boil. Instead, it transfers its heat to a separate water loop that produces steam. In a BWR, the water in the core itself boils, generating steam directly to drive the turbine. Each has specific engineering benefits and operational requirements. Finally, let's talk about waste management. Used nuclear fuel, or spent fuel, remains